So QAM, quadrature amplitude modulation. So what we had discussed till now was that for PSK or for ASK or PAM, ST equals or SMT equals AM cos 2 pi FCT, right? AM comes from a finite set. AM comes from, so let's call this set this weird S. Fine. Similarly, this I can write as real part of AM by, right?
Yes, sir.
Kirti,
Yes, sir.
agreed? Yeah. Similarly, for PSK, equals EG, or yeah, this cos 2 pi FCT plus theta m, right?
Sir,
Yeah.
wasn't it root over EG by 2?
Oh, yeah,
uh,
sorry. 2 EG by 2. I should have written in A. That would have, yeah, root over EG by 2. Fine. Yes. Just let me cross check because, yeah, this is root over EG by 2. Yes. So I prepared, since you guys didn't understand the previous interpretation of QAM, I prepared slightly different notes this time. So I wrote those in shorthand just for my reference. Anyway, for PSK, we have this. This we can write as real of agreed.
Yes, sir.
Yeah. So now one thing that I missed in the previous classes was that if we have ASK, say -3, -1, 1, 3, and so on, then when I want to send 0, 0, this is one way of doing it. And this is another way of doing it. You can either code them in straight binary or do gray coding. Just each individual symbol represents 2 bits. That's the important thing. Similarly, say you're using this for QPSK. So this is another form of QPSK. Phi 1t, Phi 2t. Suppose you are using this for QPSK, then this is another option 0, 0, 0, 1, 1, 0, 1, 1, and 0, 0, 0, 1, 1, 1, 1, 0. Gray coding. So you know gray coding, right?
Yes, sir.
So it shouldn't be a problem. So basically, since we have said this earlier that k bits map to one symbol, but I thought it would be better if we show this explicitly that this is similarly 8 PSK possibly I can draw 51T, 52T. This is 8 PSK. So you can start 000, 001, 010, 011, 100, 101, 110, 111. This is one way of doing it. Another way of doing it is 000 remains
Sir,
constant. This remain. Yeah,
so one doubt. You started with root over Eg by 2 cos of 2 pi f ct plus theta m. Shouldn't it be just gt? Like right now I'm bit confused because it was
yeah.
stated
There
of
should be a GT here. There should be a GT here.
and
There should be a GT here.
uh, we shouldn't have that root over Eg by 2
No.
then because it is in
Okay.
conjunction with.
Okay. I get what you are saying. So I get what you are saying. So okay. So actually, what I have done unintentionally, I agree. So this, yes, you are right. This should go away, and this should be simply GT. I but GT is constant, so it comes back to EG by 2. Fine. So GT is a constant function now for a finite time duration. GT is the gate pulse for this time duration.
Okay, sir. Like the Eg is the energy of the GT, right?
Yes. And GT right now we are assuming that GT is of this form, that within the symbol period it
Okay,
is
okay,
root
okay.
over EG by 2 and
Hmm.
otherwise it is 0.
Yeah. Now got it. Got it.
So actually this will become clearer once we start discussing pulse shaping and all. That's the next chapter.
Excuse me, sir.
Good.
Fine. Yeah.
Sir, we have in the ASK we have taken AM belongs to S, right? Like S has any condition or like is there any this thing?
Yeah.
Because
I'll come to S as well. So see, this is S. The constellations that I'm drawing are S. So for the purpose of PSK, that's what I was about to draw. That for PSK, actually so you can do gray coding for this, right? Or actually you can do any form of coding. You need not be straight binary or gray coding. Fine, Kirti?
yeah, sir.
Yeah, so for PSK, S equals root over EG by 2. Would you agree?
Yes, sir.
Yes. Or the process of, or what we do, so other pens are working fine today, just the default black one is, so this is the mapping that we are doing, right? This S is called the signal constellation. So it is readable still.
Yes, sir.
Yeah. So what we are doing is this, that we are mapping this to a signal constellation now. So these are the constellation points now. Even PSK or rather real part of some agreed.
Yes, sir.
So this AM for both PSK and PAM is a complex number. In one case you change its amplitude and in another case you change its phase, right? Agreed?
Yes, sir.
Yeah, so since AM is a complex number whose amplitude and phase control the modulation, we can also have a modulation scheme where we change both. Can we? Not.
In PAM, it is amplitude is changing, and PSK it is phase is changing. Now we are planning to like change both, right? That's what you're saying.
Yes. Fine. So in general, SMT equals and mm, let AM fine. Fine.
Uh, uh, Here,
Yeah.
AM is incorporating GT as well.
Forget about T right now.
Okay.
Okay. These are individual constellation symbols. When we talk about time, you will get to understand these. So right now you are just transmitting one symbol all throughout time. Forget about the pulse shape for now.
Okay,
We'll
sir.
come back to the pulse shape eventually, but that is still at least 3 or 4 lectures away, if not more. So it's good to remember that there is something like GT sitting over here, but you can safely assume it to be one or some constant function as well.
Okay, sir.
Okay, assume GT is a constant right now. We'll
Okay, sir.
discuss about GT once proper time comes. So let AM be this beast. Fine. So I can
Yes.
now define a constellation uh, theta m and rm can be anything. So let the constellation be J0. This is what? This is QPSK?
Yeah, sir.
Yeah. Now let it be. This is also QPSK still, right?
Yes, sir.
A is
Yes.
a real positive number. And if I draw this, let this small circle be of radius A and the bigger circle be of radius B. So this is S1 and let me call this, or this is S1 to S8. I can call these, or rather A1 to 8, A1 to A8. I can give these numbers.
Yes, sir.
Yeah, so this is A1, A2, A3, A4, A5, A6, A7, A8. Right? This is a valid constellation and you are changing both amplitude and phase.
Yes, sir.
Yes, but you can also view these as equals A, JA minus A minus JA, B plus J, B by root 2, B minus JB or minus B plus JB by root 2. sorry, yeah, minus b plus jb by root 2 minus b minus jb by root 2 and b minus jb, right?
Yes, sir.
So now I can write a as plus amq. This is called, so this is the in phase component from what we know, and this is the quadrature component from what we know.
So shouldn't there be a J?
Oh, yes, yes, you're right. So this is the in phase, these are the in phase and quadrature components from what we know.
Yes, sir.
So this is quadrature amplitude modulation. Fine. In general, for QAM, SMT equals AMI root over EG by 2 phi 1t plus AMQ root over EG by 2 phi 2t. Fine. EM equals mod of SM, where SM is basically nothing but a vector arrangement of agreed.
Yes, sir.
The distance between the mth and the nth point is sorry, AMI minus ANI plus fine.
So the EG by 2
EG
is
by
up,
2.
Sorry, what?
the same thing. Like EG by 2 should be outside of both AMI and AMQs.
Oh, sorry. Now fine.
Yes, sir.
I don't know why I'm doing this too often today. Yeah, writing errors. I have this in my notes, and while copying, I'm making mistakes. Happens to you?
Yes, sir. Multiple
Yeah,
times.
sorry. I don't know why I'm doing this. Yeah, so this is fine.
Yes, sir.
Yeah.
Sir,
Special case.
sir,
Yes.
hello. Sir, here we are varying both phase and amplitude, right?
Yes.
And above, sir, above you write you are written A and B, right?
Yes. Small a and small b. That was an example.
Sir, shouldn't it be equal like complete A?
That would be PSK. If A and B
Okay.
are equal, that would be PSK.
Okay, sir. Fine, fine.
Then it would reduce to PSK.
Okay.
Fine.
Yes, sir.
So special case, rectangular QAM. When AMI takes values from,
So the screen is stuck.
yeah, screen is delayed. I'll unshare and reshare. Now it's working.
Yes, sir.
So it showed itself. When AMI takes values from 1 p.m. constellation S1 and AMQ or AM small q, okay, MI takes values from another PM constellation S2. Fine. Huh? Yeah, fine. Okay,
Yes,
no,
sir.
so not fine. I have to explain this. So this, but these two sentences make sense. So AMI and AMQ you can see are now PAM sequences in their own right. You can
Yes,
see
sir.
that.
Okay.
Yes, sir.
Yeah. So now A takes values from. So let's write this S like this. Fine.
Okay, sir. So it will be like a plus bj by 2 root 2 like that, right?
What?
It will a like here it will be similar like a plus bj by root 2 something like that. A plus bj by root 2 or a.
So let let's illustrate this. So let AMI take values from -3, -1, 1, 3. AMQ take from. Fine. Let this be the case. Then plus J right? This is true.
Yes, sir.
Yes. So now when you add two sets or this means that so four values from this and two values from this. So how it can this A will contain a total of how many values? 8. right?
Yeah.
Finite sets. So let me draw this constellation. This, this, this. Fine. This is phi 1t. This is phi 2t. Phi 2t can be this and this. Agreed? So
Yes, sir.
now let's so let's start from here. -3 -1. This is 1 point. -3 -1. AMI is -3 and AMQ is -1.
So, sir, you will make 8 points right now.
Yes,
Okay.
that's what I said. There will be a total of 8 points. Any doubts with this?
No, sir. So then
Fine. So
it's not necessary that AMI and AMQ will have a same number of points, right? We can
yeah,
have variable.
that's what I'm illustrating.
Okay.
That's why I've taken the case where AMI and AMQ don't have the same number of points.
Okay.
-3. So -3 -1 1 3 and -3 1 -1 1 1 1 3 1. Fine.
Yes, sir.
This is one form of 8 QAM. Now the fun part. So I can call this 8 QAM.
Yeah.
Yeah. So others, I can call this 8 QAM.
Yes, sir.
Similarly, I will draw that again because so the example we took earlier. Is this 8 QAM? The one with A and B?
Yes, sir, this is also.
Yes, this is 8 QAM. So both of these are 8 QAM, which means that specifying by name doesn't give you a unique structure. You can have any structure for a given name. I can have any arbitrary structure for an 8QM. Makes sense?
Yes, sir.
So one question that I leave open for now is, given an 8QM, how do choose which of fine? You might want to ask this question.
Yes, sir.
So I leave this as an open question right now. We will try to answer this later. And similarly, for rectangular QAM, Fine. And then since there is rectangular QAM, there is something called square QAM, where AMI or S1 equals S2, or AMI and AMQ, in simpler words, fine. There can be something like square QAM.
Yes, sir.
So considering square QAM, the number of points in the I and Q PM constellations is root m. Fine. So there's an I constellation and there's a Q constellation. Does that make sense? I
Yes, sir.
constellation is the in-phase constellation. Q constellation is the quadrature constellation. Make sense?
Yes, sir.
Yes. So is root over m, and therefore E average, the average energy of this constellation is 1 over m small m goes for right.
So these are all for the square QAM you are saying.
Yeah, this is the special case for the square constellation. Fine. And again, since we know that AMI, AMQ, we had talked about this we had talked about.
Yes, sir.
So again, we have derived this for PM. You can do a little jugglery, and what you will get is that E average for QM equals EG by 2m times 2m into m minus 1 divided by 3, which equals EG into m minus 1 divided by 3. Fine. Root m will be uh, root m will be an even number that I believe you know. Root m will be m is an even power of 2.
Yes, sir. 2 to the power k.
Yeah. So and since there are it's a square constellation, so m will be an even power of 2.
Yes, sir.
So root m will be an a power of 2 simply.
Yes, sir.
Fine. So this and d min equals we simply replace this. Fine. Dmin we had said that is root over 2 eg. So it takes this form. Fine.
Yes, sir.
Okay, great. So now let us say, so what we have done till now, PAM one dimensional basis, fine.
Yes, sir.
Right. Now let us consider phi 1 t to phi capital MT as M orthogonal. Let this be true and let S1 so these are signals. We know that in this case is independent of M and it will be uh, root 2 over E.
Yes, sir.
D min is also the same.
Yes, sir.
And this is called orthogonal signaling. Okay, so it doesn't work horizontally. It doesn't work vertically. It will work horizontally. Consider now with right? Makes some sense for this SMLT. T should look better, guys.
So, like, what is
Yeah.
Sir,
SML of
very
T? Like,
Sorry.
like, why do we come to SML of T? Like delta F and this capital T.
So consider this signal. This is
sir,
a valid signal. Yeah.
sir, I think there should be one more m, like cos of 2 pi fct plus 2 pi m delta ft, I guess.
Yeah, there should be an M. There should be an M here, right? Fine. Copying error again. Here, this was wrong in my notes. Fine.
What is the
Yes, sir.
SML of T?
Sorry.
SML of T. SML of T.
SML. SML of T is the low pass equivalent of SMT. Right now, work we'll work only with this information that SMLT is the low pass equivalent of SMT. Fine. Kirti.
Yes, sir.
Yeah, this is fine. It'll become clear in a minute that why I am using this special signal. So this now let these be transmitted over a signaling interval capital T. We can assume that.
Yes, sir.
So now for SML and SNL, SMLT and SNLT, delta, right?
Yes, sir.
But this equals fine.
Yes, sir.
This J 2 pi delta f. Fine.
Sir, will t remain at the denominator?
Yeah, this is t outside. This is a constant. We are
Yes, but
integrating.
on after
But
integrating, would we be getting t if m not equal if m equals to n?
have I gotten to that point?
No, but integration is
We,
okay.
we are still integrating,
Okay. This is the coefficient.
right?
Okay.
Fine.
Yes, sir.
Right.
Yes, sir.
Actually, we only want this, right? Let's consider both cases. I'll give you something interesting over there. So this and this is E over T, or rather I'll keep E here, and this is 1 upon m minus n delta f capital T. This is the second part, and pi m minus n minus e to the minus j pi m minus n delta f. Fine. And yes, there is a j. There's a 1 upon j as well, and there's a j pi as well. Right?
Yes, sir.
Yeah. So 2e divided by, or 2e on one side, m minus n delta f times t here. I'll keep the pi here. 2j, this long term here. 2e 1 upon pi m minus n. And yeah, there is this e power j pi m minus n. There's this here that I will put here. Sine pi m minus n delta f. Right? equals 2e sync pi m minus, sorry, pi shouldn't be there, m minus n times agreed.
Yes, sir.
Yes. So do you have a class at 3?
Yes, sir. 3 to 5.
3 to 5. Oh, so packed afternoon. So we will continue with this on Tuesday then.
Okay, sir.
I'll upload your quiz marks in a while. Yesterday I couldn't work at all. Sorry.
It's okay, sir.
Yeah, fine. So I'll upload your quiz marks in a while by the time your class ends. Okay. So let's stop here.
Thank you, sir.
Bye.
Yeah.